All right, guys. This is a continuation of the video series that I made earlier related to U55C. Today we're going to mainly run an application on the card. Just a quick reminder of the previous video that we made. That I made. So it was. Um, all right. So first of all, we are starting from Red Hat 7.9 installation. So this was the video about that, setting up the BIOS and all those stuff. So we were able to install the operating system. Then we made a video of unboxing the U55C, then installing the card on the Dell Precision server, and what else? So this was installing the card right here in this one of the PCI slot, and then I had a video of quick by this HLS converting the C++ file to RTL. And once we install the card, we validated the card and the flashing firmware, right? So today we're gonna run an application. So let's jump into it. Let me go to this example 250. I'm gonna delete this. So I'm gonna skip the software and software hardware run. I'm gonna directly jump into the hardware because we want to run the application in the card directly from the hardware. Yep. So for that, what I'm gonna do is all right. So first of all, uh, please make sure that you have at least Vivado 2024, 2023, and 2020 installed. This might be useful later on, but today for this tutorial, we're going to use 2024 and install its corresponding XRT and the deployment and development platforms. So let's start from here. So I have installed the platform, these RPM files right here. All right, so as you can see, it's already installed, and this is installed right here in this location: OPT, Xilinx, and platforms. So this is the one, 55 2022, and yeah, 2022 is for 2024, and even for 2023, it uses 2022. So it's the same for the platform. It's the same for all Vivado version. All right. So what I'm going to do is I'm going to open the terminal. Let's minimize this. All right. So we already installed this platform, and I'm going to go to the base home directory, and we're going to clone this. I already cloned it, right? I'm directly going to go to this location, and I'm going to source the best RC file. Yep, so this is the Vivado by this HLS and by this 2024, right? And I'm gonna source the XRT as well, right? And the platform repo part. And I'm gonna make a directory. So we don't have this hardware directory yet. Just copy the earlier versions to a hardware copy. So just created this directory, and I'm gonna copy this to the hardware, right? And let's go to CD hardware, and we have this G++ version right here. It's an old GCC because we are using old operating system. Okay. Yep. So it's Red Hat 7.9, which is quite old. It's even discontinued. Now, if I run this, I will definitely an error. So before this error even running for the first time, you might find this error first, where it says boost any.hpp is not available. To fix this error first, even before this error, you're gonna get this error. You can install this. You can install them, and this will fix these errors, right? Once this is fixed, you can generate this config file by running this command, and you should have another file in config partition. Cool. And this is something else just for testing. Now, if I run the same command to generate the exe file, still an error, right? So this is the exe file that we're looking at. That is because, yeah, this is the error which I'm talking about. That is because of we need to install this. But to do that, go here, enable the repo, this particular repo right here. Once that is enabled, we install the dev tools. I'm installing a version 12 GCC, right? So yeah, once it's installed, most probably it will still give an error because we are still yet to activate. Since we have installed 12, we have to activate version 12. I think there are various versions from 9, 10, 11, 12. So we're going to activate this right here. And once that is done, we should be able to compile the code successfully. Right, cool. So, and this is the source file. This is the executable file that is generated. We are all linking the libraries, XRT libraries, Xilinx XRT libraries and all. If we go to hardware, now we have the executable files. Cool. Now the next step will be generating the EXO file. To do that, we just need to run this command right here. Right before that, this U55C.config file. The connectivity. So I was referring this document called Vitis Unified Software Platform document UG13920 discontinued, page number 301. There is some connectivity linkers such as NKSP and all. So those will be defined here. The source. So we didn't have this U55C. I just created this. So the NKSP, the high bandwidth memory 0, 1, 3, and 4. I think if you place 0, it should work as well. But yeah, anyway, forget it. I'm still learning these commands. I'm yet to figure out what NK is, what SP is exactly. But at least for now, I've made it work. So that's what I'm trying to solve. Yep. So we're gonna run this command. All right. So here it is. All right, so we have the generated samples. Hardware, yeah, the Excel file has been generated. So the next step will be running this to generate the Excel bin file, right? So let's run that. Okay, so yep, so let it run for a while. So ultimately down the line, it's going to generate this. It takes quite a while to compile, to build, to map, to route, and all. So this is a file that we were expecting, the viet.xcl bin. Um, so it's going to look something like this. Where is the log file? No, okay, I think the log file will be here. Anyway, so let it run for a while. All right, while it is running, what we're gonna do is gonna let it run for a while. All right, so okay. Once this is done, we're gonna get, as I said, the Excel bin file. Let me open a terminal here, and and we're gonna go to the location, city, hardware. No, just go copy OS. Yep, this is what we want to run. Okay. Let's source this to file quickly. Right. Yep. So that's how we're gonna get. So this was ran on the hardware. To verify all this, what we're gonna do is, while this is compiling, yeah. So it started block level synthesis has been started. So yeah, and this is the actual run on the hardware. So let us quickly check. Yeah, so while we are running, when you're running this, there might be a possible issue which might pop up, which looks something like this right here. Uh, yeah, so when you run this, there might be an issue which says like permission, please set permission, blah blah blah, and the zip file here. So to fix this, you're gonna need to run this command right here. Where is it? Yeah, so this is to program the cell, right? So it's just simple. So XP management is already here. Um, XP, yeah, so it's already here. Yeah, the same location. Program cell and this directory for this is for U250 for U55. It's gonna be somewhere around here. Yeah. So lib, as you can see, lib firmware Xilinx and whatever for the particular for U250, it's going to be here in this folder for U55C. It's here, and this is the file that we're looking as you can see, partition, and this will be the device ID, and this is XP management ID. So there are two things: XP util and XP management. So for example, XP util. So this is the device ID for XP util, right? CA001. For XP management, it will be CA000. You can see the same here. MG. Yeah, as you can see, it's 0, right? So that's what we need here. So we have all the things. The XP management program, then the partition.sa pin, which is located right here, and you can get the card ID information by running this command XP management examine. So you're going to get all of them. If you run this command, you're going to program the cell and successfully, then this error won't be coming. You'll get this instead, like test pass, blah blah, right? Now if you want to check whether what is running on the board right now, you can run this command, and my device ID is CA, and it's 1, which signifies it's utility, right? Not the management. As you can see, we have this VAD right now running on the board. I can quickly reset it, right? So again, CA. Yes. How is the compilation? Okay, synthesis going on still. Yeah. So if I run the same thing, no hardware, nothing is running. Now I'm gonna run it again. Might take some time for the first run because it's uploading as well, right? Yeah, test pass. Now if I run the same thing, yeah, we see this. Cool. Yeah. So um, oh, we can validate the device as well. This was one of the video that I created earlier already. Yeah, I can quickly run this just for the purpose of, so this will be possible after, the if you get the same error like I mentioned earlier, which was something like this: fail to load Excel bin, blah blah, error 22. Then if you do the message, you're gonna get this particular error, like yeah. So yeah, so error 22 again here, and we fix that by installing the right, by running this command. So if you didn't fix this, and if you run the same firmware, it's gonna fail here as well. It's gonna skip or fail. So you have to make sure the cell is programmed successfully or flash the board successfully. Okay, so the PCIe from host to PCIe, the bandwidth is around 12.1K megabytes per second. Similarly from PCIe to host. Memory bandwidth test might take around a minute, roughly a minute. Will be done just in a few seconds. Let's wait for it while it's compiling. Block level synthesis, that's done. Took a minute. Yep, so validation completed. Yeah, so we're good. So while we run the validation, it has already. Okay, so one thing that I would like to check is we ran this, right? This is verify DMA. I'm gonna stop right here. Okay, and yeah, so we stopped at bandwidth test, right? So the bandwidth test was uploading here. So this is what the card was running at the time. Now if I run this will be VAT kernel, right? So VAT, cool. Um, yeah, so those verification validation is running the program from the XRT Excel bin file, which has been already pre-compiled and built, right? In our case, we are building the VAT by ourselves. So in the next video, what I'm going to do is I'm going to make a GUI-based tutorial where we launch the Vitis ID, Vitis HLS. I think for Vitis HLS, I already made one video, quick video, um, where we compiled and yeah, this is the one. We compiled the C code and generate the RTL files, the Verilog files or VHDL files. And it's the same thing like we did over here where we generated .exo file using V++, right? So using Vitis, you can do the same. You can generate the exo file and or even the RTL files as an IP where you can import it into Vivado and design. Yeah, so this was one of the installation that I mentioned earlier in the videos. This Red Hat 7.9 is currently installed in this NVMe SSD card, and it's booting from the external hard drive right here. You're able to see it's right here. It's connected through USB Type C. Yeah, so the next tutorial, follow-up tutorial, will be mainly on the GUI based run. This is command line based run. And at the end of the day, I would definitely prefer a GUI based run and a mixed HLS and RTL approach, design approach. Like for example, if I want to have a very highly optimized in terms of latency or in terms of throughput, whatever, definitely RTL is the best. So it's the best way to design a system which is a combination of kernel and RTL, um, HLS and RTL together, and upload it into the Alveo using this approach, the command line approach. But it's always good to know the GUI approach as well. So that will be the next tutorial. That's all for today. Am I missing anything? No. All right, so I'm gonna stop the run right here. Cool. That's all for today. Ciao, guys.